In this video, we'll maximize the mixing entropy. When we mix different types of molecules, the total entropy increases, and that increase is called mixing entropy. The mixing entropy can be expressed as -n times Kb times the sum of the product of Pi and the logarithm of Pi. N is the total number of molecules. Kb is the Boltzmann constant. Pi is the probability of a molecule in the mixture being type I. So P sub I is actually just the mole fraction of type I. And how do we maximize the mixing entropy under this constraint? We will have to use the Lagrange method. First, we define the Lagrangian to be the mixing entropy minus a constant alpha times the sum of Pi minus 1. This is because the sum of Pi must be equal to 1. So this L, this Lagrangian, is equivalent to this mixing entropy, and maximizing L is equivalent to maximizing the mixing entropy under this constraint. The sum of all probabilities is 1. At the maximum of the Lagrangian L, its slope should be 0. Therefore, we can replace L with its expression and solve this equation for every single type of the molecules. To do that, we look at type 1 first, and we have the exact differential of this Lagrangian over the exact differential of P1. This has to be 0. And then we replace this mixing entropy with its expression in terms of probabilities. Now I have one sum here and another sum here. In this sum of many terms, only one term depends on P1. That's P1 times the logarithm of P1. The derivative is simple. It's logarithm P1 plus 1. In this sum, also, there's only one term that depends on P1, and that is just P1. Therefore, the derivative of this is 1. You have alpha times 1. Now we solve this equation. We have the logarithm of P1 is equal to negative alpha over nkb minus 1. Again, n is the total number of molecules and kb is the Boltzmann constant. We can do this for type 2, type 3, and type 4 and get the same expression. So all those probabilities must be equal. And we have this long equation. All probabilities are equal, and therefore P1 is equal to P2, etc. They all have the same value, which is 1 over m. M is the number of types of the molecules. And then by plugging this 1 over m here or here, we can have the expression for this constant alpha. Alpha is the total number of molecules times the Boltzmann constant times the logarithm of the number of types of molecules minus 1. More importantly, we have the expression for the mixing entropy. Now it's maximized. N times the Boltzmann constant times the logarithm of the number of types of the molecules. Again, N is the number of molecules, and M is the number of types of molecules. So if we mix 1 trillion different types of molecules versus 1 million different types of molecules, well, the as mixing of 1 trillion different types is only 2 times the mixing entropy of 1 million different types of molecules.